accurate maps for us. If you want to view and download them yourselves, you can visit science.nasa.gov/eclipses. So now let's welcome back NASA heliophysicist Dr. Kelly Korrick. Kelly, how are you feeling about today's eclipse?
I'm excited for everyone, and I know those clouds are a little worrying in Iceland. That's one of the reasons we had the plane, but also joyful to see the balloons that are going to be launched, as well as seeing it in Spain. So really excited.
Yes, and I'm sure the NASA pilots must be excited as well in the plane.
Yes, exactly. It's a great view. It really is a great view from that.
So here we're seeing a live view from the WB-57 aircraft sensor right now. They're moments away from seeing the moon's shadow hit Earth and also chasing the eclipse. And we haven't actually seen the view of the corona yet from the nose, but they will be capturing images once totality hits Iceland. And on the right-hand side, we're seeing a partial eclipse from Norway, which is really exciting. So we have places across Europe that will be able to witness a partial solar eclipse. There'll be many, many people here that will be able to experience this amazing celestial event. So let's see how many, we're about 6 minutes away from totality in Iceland.
Yeah.
What do we expect to see right before totality?
Right, so right before totality, we're in that partial eclipse that's going deeper and deeper, and you start to see things go dark. So even if there are clouds, it's going to get a little bit darker. The weather is going to drop too, because again, you've blocked out some of the sunlight, so you're going to get cooler. There's some wind that'll pick up. So the eclipses are really full body experiences. You might also notice that animals react as well. It's not just humans that experience this, but if there are any animals, they might start to pretend that it's nighttime or realize it's nighttime and start to kind of nest. And this is very unique for that part of the world, because right now they're on almost 24 hours of sun. So they are going to be a little shocked by this. And so you'll be experiencing a lot of different things, even if you don't get to see the beautiful corona.
Yeah, I'm thinking about everyone on the ground in Iceland right now. They may be seeing clouds, but can you tell me, how does the climate shift when an eclipse happens? Because I've heard that the weather can change drastically.
Definitely. So from personal experience, in 2017, I was in South Carolina, and there were thunderstorms. And during totality, it parted just around the sun and was able to actually fully enjoy the eclipse and see my first total. That was my first total solar eclipse. So there is hope that the clouds are influenced by that change in day-night, that eclipse that's coming through. So we're hoping that some of the winds and some of that changes could change things for Iceland.
Okay. So we're seeing right now on screen a live telescope view from Spain, and that's because the telescope views in Iceland are obscured by clouds. But as Kelly mentioned, I'm hoping that the clouds will part and the weather will change for them. Anything can happen at this point, right?
Right, anything can happen. And also, we'll talk about it a little later, but the balloon experiments, they are testing the atmosphere. The atmosphere of the Earth is still being affected, even if there is cloud cover, and that helps us with predicting weather models. So it's not just about the coronal science, which is something that I'm very passionate about, but it is also about understanding our planet and how it interacts with the sun and the light that we're getting from it. And you see, we're starting to see something in the WB-57. It's getting very close. They were zooming in there, so that's
okay.
Oh, wow.
Okay, so everyone who's watching right now, the right-hand box, you will see the live views from the WB-57 aircraft. That's where the NASA pilots are chasing the eclipse from the skies. So Kelly, can you tell me what are the benefits of observing the eclipse from up there?
From observing up there at 50,000 feet, wow, okay, so I'm looking at these are great. 50,000 feet, you're able to get above all the clouds. So they're above all the clouds, and we're able to, again, allow it to overtake us, so they get a few more seconds of totality. You saw that beautiful pink filament on the sun. That is something that Amir talked about, is that filament, that material that comes off the sun that can actually create space weather and affect our power grids here on Earth. It can affect our GPS. So if you ever use your maps to get anywhere, that's something that we need to understand and be able to predict. It also affects our astronauts, our dear astronauts, so making sure that they're okay. So those things are really important to study, and one of the reasons why we have the WB57. It's a little hard to see, but in the words on the right-hand side, you see that pink filament now on the WB57 feed, which is on the right-hand side. And yeah, so you can see it in the NVIS area, now kind of right in the center. You're seeing that prominence, and so this is amazing data. And it might not look as crisp as we're used to. You know, we're used to 4K down here, but this is really data a scientist can love, because this is telling us very specifically about part of the data. So it's like taking only a little part of the TV stream in and really getting the information about the iron or the oxygen or the specific composition of what that's made of. And if we know what it's made of, we can do more science with it.
So we're about like a minute and a half away from totality in Iceland. And so we have a minute and a half for the clouds to part. So the sun view that you're seeing here, that is not of Iceland, but that is of the partial eclipse in Spain. Iceland is still being covered with clouds, but totality will hit them in about just a minute or so. And luckily, our airplane, the WB57 aircraft, they're going to be getting clear views of the eclipse from the skies. So we're going to be seeing what the camera on the nose of the plane will be seeing in roughly 1 minute, which is so exciting for them.
So exciting, yes, definitely. And you are starting to see some of the what would be a diamond ring effect. So those little pink things that you're seeing, this is what happens when light passes through the valleys of the moon. So you don't have a perfect circle in the moon. It has those craters, and there's that diamond ring effect.
Oh,
so
wow.
yeah, so just absolutely beautiful. And that's when you still should have your glasses on. And when that ends, that's when we're able to do it. And I want to comment, this is an experiment, right? And so this is part of the reason why we're seeing kind of the arrows or the crosshairs go in and out. We are real time. This is real time live.
Yeah.
How science happens is that we are trying to make sure to make adjustments and make sure we're getting an image.
Wow.
Yeah.
So we are 7 seconds down to totality in Iceland. This is really exciting. We're getting a shot of the ballooning experiment as well. This is the Nationwide Eclipse Ballooning Project. They've been launching balloons for the past 24 hours leading up to this eclipse, which is so exciting. And I can see that they're getting really excited as well, despite the clouds, because they can actually still collect data even though they can't see the eclipse. Is that right?
Exactly. They can still collect data. They are still experiencing a little bit of that darkness. It's obviously darker. See, it's definitely darker, even though you can't see the corona itself. And a little bit looks like sunset around the 360 degrees. And you know, hopefully we'll see this in Spain, where it'll be very vivid imagery there.
So it looks like totality has hit Iceland, which is so exciting. You can see that the ballooning team is engulfed by darkness here. So that is so exciting. I can see them smiling. Oh my goodness. So why do we see a 360-degree sunset during an eclipse?
Because there is light on either side. It's just simply blocking out in that specific shadow. So it's like the sun has gone down just in that one location, but you know, the rest of the earth is still illuminated. So you still have oh wow, that is images of the sky and the airplane. We are seeing the airplane.
Wow, so we have experiments happening in the air and on the ground in Iceland, which is so exciting.
Definitely.
Wow. So, and then what we're seeing now is the partial eclipse happening in Norway. They will just be experiencing a partial, but in Iceland, they are experiencing totality right now. We have experiments, balloons capturing data in the skies, and also a plane capturing data in the skies as well.
Yes, we do. And it's really interesting looking at the sun. There are some features, those lines that you see, the dark lines, those are magnetic features, and those again are the exciting things we want to know about for space weather, and so to better understand that. So the sun has given us some very interesting things to look at, and those experiments will really, really help us.
Yeah, and so this is why eclipse observations and eclipse chasing is so critical, because even though they happen often and even though we know exactly when they're going to happen, you never know when the weather will just obscure your view. So we want to take every opportunity we can to get observations.
Definitely.
So, okay, so if you were in Iceland and you were either seeing clouds or you were able to see the eclipse, please share your experience with us. We want to know what you experienced on the ground. Please tag @NASA wherever you're watching. So we have a lot of questions coming in here from social media. So Kelly, shall we dig into those questions?
Yes, let's dig in.
Alrighty, so we have Bo on Facebook, and they ask, are we really going to lose gravity during the eclipse?
No. We are not.
Okay.
Gravity, really, the stuff that sticks us to the Earth's mass has not changed because of this eclipse, and so we're going to stay grounded on this Earth.
Okay, noted. Gravity will not change. Okay, so we have another question from X, and they ask, how much can we actually learn about the sun during just a few minutes of totality compared to years of normal observations?
It's really about having all of the observations, right? We definitely need that totality because the moon just happens to fit so perfectly over the surface of the sun that we can see from that surface outward for that space weather, whereas some of our instruments aren't quite that close in. So we need to knit them together and use both the couple of minutes from the eclipse as well as the years of the observations from our NASA satellites.
Okay, well, I'm glad that we have both ways of getting observations.
Exactly.
So we have another question here from Elinu on YouTube, and they ask, why does the weather change in a solar eclipse?
That's a good question, and I think that's something still trying to be understood. But if you imagine you've stopped heating something up temporarily, so things sink, right? When things get cold, they tend to sink, and so the air is moving, and there starts to create winds. And when you create winds, you start to cool things down. So the weather changes due to just turning on and off the light alone, because the sun is so important to us in actually regulating our weather.
Wow. Okay, so we have another question here from Frank Perez on X, and they ask, for sending teams to do research in the path of totality, how do you balance the crew training value of Iceland's terrain against the statistical odds of clearer skies in Spain?
And we definitely addressed both, right? There are great things to do with the atmospheric work, especially in the Arctic areas, for the balloons that we sent to Iceland. And then we have teams in Spain also doing that. So it was a balanced portfolio. We made sure that we had both types of experiments available.
Okay. Thank you so much. So keep your questions coming in. We'll be answering more later on in the show. And so earlier, I also mentioned that we had questions for you, the viewers, as well. You can head over to NASA's Twitch and Instagram to weigh in on a couple of those. So here are some of these questions that we posed to you. So Kelly, let's see what those questions are.
Definitely.
So if you had to pick where you'd watch the eclipse from out of these special locations listed,
yes.
I'm going to ask you this, Kelly. Which ones would you choose? So we have the International Space Station, a high-altitude plane, an observatory telescope room, and a NASA chase jet.
It would be a tough choice between International Space Station or high altitude plane. They've got such a huge overview. It's great.
Yeah, I think I would choose the same too.
Yeah.
So thank you to everyone who has participated so far. We're going to check back into those results a little bit later on. So next, let's head back to the ground in Iceland. We have another NASA-funded experiment there involving balloons. Students that are part of the nationwide Eclipse ballooning project. They've been launching balloons continuously throughout the eclipse, and we're going to be chatting with them live from Iceland shortly. But first, let's learn more about their Eclipse project.
Teams of students from across the United States have